All right. Hi, I hope you can hear me. I'm just going to share my screen. I do apologize for the noise here. I'm not sure what's happening outside, but I don't want to bother myself with that. Anyway, just going to start off by asking if people have any questions in regard to what we've covered so far. I don't know if you guys have had a chance to look for Java-specific testing frameworks, and hope you've played around with those frameworks. Has anyone bothered to look into that? Hello?
We're here, sir.
Yeah, there was a question. Have you bothered to look into any Java-based testing frameworks? Okay, no answer. At what stage Jesus, how far did we go last time? Did we start looking at this part, development testing? We did, right? I want to, that's okay, I'll check myself.
No.
Sorry?
No, we didn't.
Okay. Yeah, I don't know, this is weird here. Old age, I suppose. You start forgetting things, I guess. I don't know. You just seek to the last of the recording so that we are certain where we ended.
Some of you.
Where we ended. Okay, so it was slide number 19. Beautiful. Okay, this is good stuff. Well, if you've chosen not to look at this testing framework, that's your own problem. You will be forced to, though, next year, right? Otherwise, I mean, how are you going to develop software associated with whatever project you'll be working on? I don't know. Don't have the answer. Don't even know what you're going to be working on. So, so we're just going to briefly talk about development testing. I mean, just because it turns out that when you're developing software, it's likely the type of testing that you get to experience the most as a developer or as a software engineer, I suppose, as a software developer, a software engineer. And it mostly involves program testing, essentially. So development testing includes all the testing activities that are carried out by the development team, right? So the team that is responsible for developing the software. And this makes sense, right? Because this is the type of testing that is conducted as the software is being developed, right? So you want the people that are developing the software to participate in this testing process. Now, there are different subcategories of development testing. So you have unit testing, component testing, and system testing. So under unit testing, we've already mentioned some of these things. You focus on individual program units. So things like functions, methods, classes, right? These are the things that you'd be testing. And the goal here is to focus on testing the functionality of these components or these program units. Then component testing is where you get to test the integration of the different individual program units. So perhaps you might be interested in testing a particular class, in which case you'd be combining, you'd be testing all the different program units that compose that class, all the different functions and methods, maybe constructors even that are associated with that particular class. But really, the vast majority of the time, you're looking at significantly higher level program constructs, right? So actual specific components, which is why the focus is on testing the component interfaces, right? So if you, let's say, have decided to say you're going to take a module-based approach when you're implementing your system, what you'll be testing are the different interfaces associated with those modules, for instance. And then under system testing, what you're doing is you're just testing you're testing the system as a whole, right? Once you integrate all the different components associated with that system. Right, so unit testing, right? Again, you're testing these smaller program constructs as individual components. So if you're developing a calculator, for instance, I don't know if you did this with Piela, Mbewe, right? Where did you teach you how to write a calculator? You develop a graphical user interface for a calculator or something that looks like this. Did you do this with Piela, Mbewe or something? Did you write something like this? No? Maybe not a complex calculator like this, but this simple mode. You did this, right? I don't know, no answer. That's fine. So the thing is, what you'd be doing under unit testing is, if you look at this calculator, right? If you're developing a system like this, what you notice is that when I'm adding 7 and 8, like so, and say equal sign, there's probably a function, right, or a method that is responsible for that, right? It's an individual method. It's different from the function or the method that allows me to subtract 8 from 7 so that I get -1. So what I'll be interested in doing is testing these individual functionalities, smaller things, right? That result in some meaningful output or something. So another way of looking at unit testing is it's an opportunity for you to perform defect testing, right? So you come up with your test cases and then you go through some of the things we discussed last time. Again, some of the list of things that are falling under the third bullet point here, this is not exhaustive. In certain instances, things like object classes might not be applicable. For instance, if you're developing software, but by not taking an object-oriented approach to development, then there'll be no classes, right? So it would be pointless for you to test any objects or any object classes because they won't exist, right? But fundamentally, for the most part, these are some of the components that you tend to test, really. Right, so when you are testing, testing a function or a method is pretty easy, right? Public class, ICT 3020, and then you define a class. Just do this. Public class, ICT 3020, and then you do this 1, 2, 3, 4. Public static void main, whatever. Stuff that Kiela taught you or something. Then you say system.out.impline or something, and then you say call a method add me or something, and then you feed it 2 + 3 or 2 + 2. What we're saying is you're doing this with when you're testing these individual functions and methods, what you're testing are things like this public. Obviously, you don't test the public static void main, right? The standard method that exists. The people that wrote this method already tested it, right? The main method. So what you'd be interested in testing is something like add me here. And you know that your add me will have, I guess, an int number 1 or something, and int number 2 or something. And then you come here, you say return number 1, come on, really, plus number 2 or something, right? So the idea behind unit testing is you're interested in testing things like this, right? So if this was your calculator, then what you'd be testing are lines 22 to 24, lines 26 to 28, where you have subtract me, and then you say return number 1 minus number 2 or something. We just made the calculator, I guess. I don't know. Maybe we did, maybe we didn't. You say multiply me or something. Do you understand this? Multiply me. Where you say just return this times this, right? And then under object class testing, if you have if you've taken an OOP approach, object-oriented programming approach, then your complete text coverage of testing this class will involve you testing all the operations associated with the object, right? So remember all these operations. These are operations associated with an object that I'll instantiate using this class, right? So if I create a new object of type ICT 3020, then I'll be testing these things here that fall under it, right? So also some of the things that you do is setting and interrogating object attributes, right? So the variables that you define, right? Class variables or attributes that you define, if you do that, right? And then exercising all the different possible states associated with the object itself, which is essentially dealing with constructors here. So if inheritance though does make it somewhat difficult to design tests associated with the class objects. That's something you have to put in, you have to take into account here. Because of the association that exists in between parent classes and child classes, obviously, or superclasses and subclasses. When it comes to unit testing though, right, what you need to remember is that you don't have to manually do things. So let's say you have the add me function, which adds 2 numbers. You don't necessarily have to, and this is what your novice programmer will do, right? If you just learned how to program for the first time, you most likely manually test your function. So you write this class, come up with this class here, and one of the ways in which you test this class, right? I guess we could do this actually for fun. One of the ways in which ICT 2020.java, one of the ways in which you test this class here, this is Java ICT 2020. Wow, this is the thing here. What happened? What happened to you, sir? Right? What have I done wrong? Okay. So it doesn't matter. Anyway, so you don't have to manually. Oh, there we go. You're saying let's let him fail or something. Type, right? Don't fail. I did this for years, right? It's like riding a bike, I guess. You don't forget these things once you do them once or something. I'll ask you, why do you do this? Well, I don't know why I do this, but oh, it's not static again. Okay, that's fine. It's class level. Anyway, so what we're saying is that all these things that I'm coming up with here, right? Just add the static here. All these things that I'm coming up with here. If I'm to test this function, you notice that hard coding this as 2 plus 2. Testing it would involve me just checking if I'm going to get 4 here. Am I going to get 4 here? Well, maybe I am going to get 4, maybe not, right? So if I run the Java ICT 3020 here, if I get a 4, then I'll know that, oh, my add me method or function actually works, right? But what we're saying is that you don't have to do this. You can automate the test, right? All you have to do is you identify your test cases, and then you narrow down to a specific testing framework, depending on which programming language you're using. Your average programming language, you typically have test frameworks already available. This is such an important part of it's an important activity that is a part of programming, that people have written a ton of testing frameworks. All you have to do if you decide to go down this road is identify a test framework that works for you. And it turns out that the idea underpinning these different test frameworks is the same. What might differ is the syntax, right? So you use things like, oh, describe this or expect this once you feed it that sort of input or something. Anyway, so in automated unit testing, you make use of automation framework. So in Java, you have JUnit. In JavaScript, you have fancy things like Jasmine, Mocha, not the Mocha, the coffee, but I'm guessing it's named after coffee, right? Popular and easy to use frameworks, automation frameworks like Jest, for instance, right? There's a whole bunch of them, actually. I mean, if you're a JavaScript fan, what you can do, right, is just go online and just say ranking JavaScript testing frameworks, right? And I'm sure there'll be a ton of them. I wouldn't be surprised if Jest is, oh wow, Jest is top on the list, right? Jest, Mocha, whatever this list is. Some of these I haven't used. I never knew Selenium was. I've used Selenium, but I didn't know it was a testing framework. The same goes for Java, right? Ranking Java testing frameworks. JUnit is just one of many frameworks. Do you understand this, right? So you have to do is identify the testing framework that you want to use, and then learn the syntax, and then you just go ahead. Now, once if you spend time and focus your attention, you read up more on testing, you likely is it behavior-driven programming? You likely come across things like test-driven development. I think we talk about test-driven development. I think so. Where it's funny, really, where you start off by writing tests before you write the code, right? But anyways, so the test cases are code. So if you're writing in Java, you write Java code to test. Now the question is, what do you use to test the test code, right? Well, I don't know, right? Anyway, so these frameworks, these automation frameworks that you tend to use will provide you with generic test classes that you can extend. And I think this is applicable to Java. In JavaScript, there's nothing like extending. I mean, if you're doing some basic testing, you don't have to extend anything, right? But it turns out this statement is associated with frameworks like JUnit, I suppose. So you can extend the generic test classes to suit your needs, essentially. And they can run all the tests that you have implemented and report. Now, tools like Jest, for instance, I don't know if, there's probably no example. I wanted to give an example, but what Jest will do sometimes is you can configure it in such a way that an HTML document, and I think this is done automatically, an HTML document, a report is generated for you that shows you the results of the tests the automated tests that you'd have executed, right? Which is quite useful, really. Right, so in terms of the different components that make up your typical automated test here, you have a setup part, right, where you have to initialize the system with the test cases that you have derived or come up with. And these test cases, remember, we've mentioned that a test case is nothing more than a list of inputs. So you have input, what typically happens when you're using a test case here is you're working with three things when you're testing, right? Your test case will have an input and expected output. I guess we can just call it output. And then you have the actual output, right? So what you're doing essentially when you test is you compare the the actual output with the expected output. If the O and the A are the same, then your test has passed. If they're not, then it's failed, right? And then you have the core part where you actually call the object or the method to be tested, right? And the assertion, which essentially checks if the expected output and the actual output are the same, right? This is the assertion. If it evaluates to true, then you know that they're the same, then your test is successful. If not, then it has failed, right? So I just have a few screenshots here showcasing some popular testing frameworks. JavaScript, by the way, not Java. Unfortunately, I part ways with Java myself a long time ago. So most of my examples are in JavaScript, but the concept is the same, really. So fancy frameworks like Jest, and really the sheer number of testing frameworks that you have at your disposal tells you implicitly how important that activity is, right? testing is such an important part of programming, although a lot of people tend to neglect this. They'll prefer to manually conduct these tests, which is quite unfortunate if you ask me, really. So you have tools like Mocha as well. I do encourage you to look into these things, if you will. The beauty with some of these testing frameworks, if you're a JavaScript fanatic like myself, is that you can pretty much make use of them even within these popular frameworks that you'd use, right? So backend frameworks like Angular, for instance, Vue or Backbone, JS or something, they can all make use of this testing framework because essentially they are based on the language itself. So it really doesn't matter if you're using a specific type of framework, right? Because the framework is based on a pre-existing language. Anyways, so another example, JavaScript framework is Jasmine. If we were to look at the syntax, what you will realize is that the way that you get to define these tests, right? The way we write your tests is pretty much the same. Some parts we involve you following certain prescribed conventions, like for guest, for instance, what would be required of you is if you have a function, let's say you have a function or a function called or a file, a JavaScript file called addme.js, addme, not ms.js. Your test will be created in a file addme.test.js, right? So this is where you have your code, and then you export whatever function you want to test in here, and then you import it in here or something, right? So it's the same approach, I'm guessing, for these other languages, really. All you have to do is just spend time and learn exactly how to use these testing frameworks. Right. So your test cases should show what is to be expected once you execute your test, obviously. If there are any problems, any defects, your test case should be able to tell you that. So your test case will signal whether the test has failed or has passed, right? And so this leads us into our discussion that we had before, where you have defect testing and actual testing, right? Normal testing. So where the first part will allow you to determine the normal operation of the program. So if I feed an addition program with 2 and 2, it should give me 4 something. And then the other part is the one where you expect the test to fail, right? Given predefined variables or something. So defect testing. So it turns out that there are several techniques that you can use when you're coming up with these test cases, right? I did mention in previous sessions that we've had that it's not possible for you to test all the potential values associated with a particular function, right? You have to be smart about this. So if you've created a program that adds numbers, integers, how many integers do we have, right? Countless integers, from -infinity to +infinity. It's pointless for you to test all of these potential test cases, right? So techniques that you use is you can partition the test, right? Where you identify specific groups of inputs that exhibit similar characteristics. So for instance, if you're adding numbers, what you could do is you could say you're going to play around with negative numbers first. So try and test if this addme program is able to properly add 2 negative numbers. The other group of test cases that you can identify is all positive numbers, negative and positive number, positive and negative number, a 0 and a negative number, a 0 and a positive number, and then you'd have exhausted the potential groups of numbers associated with the function that you want to test. You understand this? It's not always possible for you to test all the potential inputs. It's like a password, right? If you are testing a login module, for instance, how many potential usernames are you going to test? Countless of them. And so you better be smart about that, where you identify groups, right, that have common characteristics or traits. And then you get to choose the test from within the groups. You sample out just 1 or 2 test cases from that particular group, and then you're done with your testing. Now, granted, I mean, this approach, obviously, like we said earlier on, might ultimately result in in bugs being identified once you deploy the system, but that's fine. You'd have at least attempted to test all potential values associated with a broad spectrum of input values. Right. Yeah, so sometimes it's important to work with guidelines as well, right? Where you follow through with the predefined steps on how to identify potential test cases to use here. So some generic testing guidelines might include that you choose inputs that, sorry, if you could just pardon me here. This looks like one of those important calls, but I'll just send this person an SMS to say I'm in class or something. That would be nice, right? Now I use the I'm in class excuse a lot, but I don't lie, it's true, I'm in class right now. I do apologize, you just give me a second. These people start saying he doesn't call something, doesn't pick up. All right. Yeah, depending on the type of implementation you're working with, you might also want to design inputs that will cause things like buffer overflows, for instance. You want to make sure that you sort of like try and repeat the same input or a series of inputs numerous times, right? And this is an idea that is associated with any type of experimentation. Actually, if you're conducting an experiment, an empirical evaluation, for instance, what they will prescribe is that you take things like 3 run averages or 5 run averages. So you repeat the same thing 3 times or 5 times to rule out the possibility that what you got was just by chance, right? You also want to make sure that you at least try and force invalid inputs to be generated as well. Like you don't want to just stick to the more positive outcomes. And you also want to force the computation results to be too large or too small. Just generic guidelines, really. And then under component testing here, just to remind us that when you're developing software, there'll be several, if you're taking an object-oriented approach, for instance, you have different classes or objects that will be interacting with each other, right? So what you want to do is to test that sort of interaction that takes place. The example that's given here is a weather system application where you might have different objects that perform different functions interacting with each other. So you want to test the interfaces associated with the classes, right? There's usually predefined interfaces that you can use to test this functionality. I was tempted to check that message, but if you could use the microphone, that would be good. So the goal here is to showcase that the interface behaves according to the specification. I'm trying to think of an example that we could latch on to here. I don't know. I wanted to use like a calculator here, but I'm guessing you get the point here, right? All right. Interface testing will involve identification of defect faults, right, that are associated with any interface errors that might exist. So the types of interfaces that you might want to focus on here, things like parameter interfaces, which will normally be associated with data that's passed on from different methods or procedures. So shared memory interfaces, this is perhaps if you're developing some low-level program or something. Procedure interfaces associated with subsystems that are composed of the system that you're implementing. And then finally, system testing, right? So unit testing, component testing, system testing is associated with the testing that takes place once you are done programming, or at least once you're done with a major phase of programming, right? So you've completely implemented a system as a whole. The next step is you want to integrate the different components that are composed of that system. So you want to test that integration process. So again, here you're testing the interaction between the different components once you integrate them as a whole, right? Checking for things like whether the components are actually compatible with each other. Yeah, then you'll be interested in trying to see what might come out of the behavior of the system as you're testing it as a whole. I don't know at what stage we start talking about the different alpha and beta testing. And so under system testing is where you have, if you've come across things like alpha testing, beta testing, this is where you get to do those things, right? Because the testing there gets to involve testing the system as a whole, and not the individual smaller programming units or components that comprise the system. Right, so during system testing, it's entirely possible that some reusable components that would have been developed would need to be integrated into the system. And you need to test that as well. We discussed this, if you remember, when we were looking at the different types of approaches when you're developing software. We highlighted the fact that it's entirely possible for you to reuse pre-existing components. There's a danger, right? Because you don't have control over these reusable components, there's a danger that they might not behave the way you expect them to behave. And so you want to make sure that you test the integration of those reusable components. Even though when you're downloading these reusable components, right, there's usually some sort of guarantee given to you, right? They'll even provide you with documentation of tests associated with the reusable components. But the key thing here is to make sure that you ascertain the fact that once integrated with the system that you're developing, the reusable component will behave as expected, right? People don't develop login modules anymore, right? There are reusable components that you can get off the shelf, freely available. So this second point here is associated with what I just mentioned here, because you don't have control. Remember, these off-the-shelf components are developed by a completely different team of programmers, right? So you want to be very careful when it comes to testing the reusable components. Right, and so if you are working for a large software development shop, obviously it's possible that that the people that will be conducting the testing would not have participated in the overall programming of the software itself, in which case more details will need to be provided to them so that they're able to effectively test the different components of the system. So in terms of some of the policies that you might want to come up with as you're testing the system here, you want to make sure that the test is exhaustive as possible, comprehensive. Although it's not possible for you to test for any potential defect that may be associated with your system, but you want to design your test strategy in such a way that you conduct a comprehensive test. So some example policies that you might come up with here will include that all system functionalities that are accessed through menus should be tested, for instance. Right. So if you're developing a GUI-based application like this, what you're saying is that as part of the policy, you could decide to say all of these functionalities that are associated with menus should be tested. Why? Because you know that these are probably going to be some of the most commonly used functionalities, right? So you want to make sure that these are comprehensively tested. Example policies will include combinations of functions, right, that are accessed through the same menu should be tested. When a user needs to provide input, all functions must be tested with both correct and incorrect input. But again, these policies would depend on the type of application that you are implementing, and more importantly, depend on the development team or the people that are conducting these tests. And it's mostly, it becomes more clear with time as you develop expertise and experience developing software and testing software. All right. Yeah. It's a little bit about so-called test-driven development here, which has more or less gained a lot of traction especially when it comes to languages like JavaScript. Most people advocate for a test-driven development type of approach, where you don't wait until the end for you to test, but the testing takes place as you're developing the software. So development of the software and testing is interleaved. So as you're developing the software, you're also testing it. And in fact, increasingly, and I think I mentioned this already, you have a situation where you write the test before you actually write the code, right? So the test will actually inform what sort of code you're going to write. And so you end up developing the code incrementally here together with the test. So test-driven development is obviously, from the explanation here, you can clearly see that it's associated with agile techniques where you don't take the approach associated with a traditional software development model where before you test, you have to completely implement everything, but rather you go through several iterations, right? And within the different iterations that you go through, you develop, you test, you expose whatever it is you've written to the user, right? So, and of course, that's exposing what you've implemented to the user as part of testing, right? That's implicitly user acceptance testing, so that you are developing the correct thing or the right thing, something that the customer or the client expects. But of course, you can also use test-driven development as part of a plan-driven development process, like the waterfall model, for instance. So you'd incorporate this in the implementation phase of the waterfall model. So in terms of the visual representation of test-driven development, this is what you have here, right? You identify new functionality, you write a test, you run the test. If the test run is positive, if it passes, right, then you identify a new functionality, you write a test, you run the test and go through this loop. If it fails, then you re-implement the functionality and you refactor the code or something. Right, so just to kind of explain this workflow here, the identification of this functionality here has to be at a very low level, right? So at the functional level or something, because remember, this process is supposed to be incremental. You want it to be as small as possible so that it's easy to test. The fewer the number of lines of code you have, the easier it is to test. That particular code fragment. The larger the lines of code, the more difficult it's going to be for you to test. And the difficulty comes in when you need to identify where the problem actually lies. And indeed, most of these testing frameworks that you end up using will typically, at least this has been my experience with JavaScript, they'll point out the line of code which is problematic, or the line of code that you're testing. Right, so you write, then you write a test for this functionality that you've identified, the new functionality. You run the test along with other tests that you've already implemented, and then you implement the functionality if it fails or something. Once all the tests have run successfully, you move on to implementing the next program fragment that needs to be implemented. So there are certain obvious benefits associated with test-driven development here. Yeah, you're more likely to conduct a more comprehensive test because most, if not all, the code fragments will pretty much have a corresponding test, right? So at least you're assured that you're going to test the code fragments at least once or something. And then you also implicitly conduct regression testing. It simplifies debugging, right? Because when your test fails here, the process that you follow through with is implicitly debugging, really. You want to identify what the problem is and then you fix it, right? And then in the process, as you are conducting this test-driven development, in fact, what you're doing is you are to a certain extent, you are coming up with the documentation associated with the system, right? And the documentation is in the form of these tests that you're writing, right? So make your life a lot easier when it comes to generating documentation associated with your system. All right. So this idea or notion of test-driven development is associated with development testing, by the way. But we're just trying to highlight that will typically be mostly used to a specific type of process model that you'd be using. And specifically, it would be like an agile technique. But besides development testing, there's release testing. So once you're done developing, you want to release the system that you've developed, right? It turns out that you need to test the system as a whole, right? This is part of release testing here. So what you'd be doing here is you'd be testing a particular release associated with your system. So it could be maybe the initial release, like in your case, assuming that these initial feasibility prototypes that you're implementing were comprised of the full-fledged system, you would have had to test the system that you initially released, right? So that would be an example of your release testing. And depending on the sort of feedback that you get back, usually the initial release will comprise of a number of bugs. And so you'd have to re-implement some features, make changes, add additional functionality, and then you conduct another test. So all these tests that you're conducting are what we are calling release testing. And the primary goal of release testing really is to guarantee to the client that the system that you've implemented is good enough for use, right? So what you're doing here is you're showing that the system adheres to the specified functionality in the SRS document, really, including all the different ADTs, not just the functional requirements, but also the non-functional requirements. So things like performance, right, dependability. And this actually includes things like what Jackson highlighted with the GPA application, where I don't know if you'd say it's dependable here with the errors that normally manifest itself, something. A key thing to note about release testing here is you can view it as black box testing because you're not really concerned with the functionality. So you're just interested in the overall function of the system as a whole. You don't care how it was implemented. And the assumption you make here is that before you get to this stage, unit testing and component testing would have already been performed or conducted, right? So black box, this is essentially black box testing where you don't really care so much about the gory details of the implementation of the system as a whole, but you're just interested in the functionality of the system once implemented. So release testing effectively is a form of system testing here because you're testing the system as a whole. But I guess some subtle differences associated with release testing from system testing is that typically when you're conducting release testing, a separate team that's not involved with the development would have to test the system, right? So when you're testing these different releases, it makes no sense that you involve the development team to be a part of the testing process. You need an independent team of assessors to test the system. Which is why usually alpha testing or beta testing is normally done by a group of would-be users of a system. And I always use Facebook here as an example because before they roll out a particular feature, they'll just identify a small segment of users. They've changed some part of Facebook. They'll just expose it to a small group of users. That's a classic example of beta testing, right? The people that will be a part of the beta testing are not involved with the system development. But classic system testing would typically be done or could be done by the development team, essentially. Another way of looking at the differences between release testing and system testing is that with system testing, the development team tends to focus on trying to identify potential bugs associated with the system, right? But the objective of release testing is to check if the system meets the requirements. So it's good enough for external use. So can you roll out? Once you do a beta testing and you're happy with the results, you roll out the system to the entire user base. All right, so again, as part of system testing, I mean, one of the EDTs or the non-functional requirements that you tend to focus on is things like performance testing, right? And also reliability, right? So what you're interested in here is to try and determine the profile of the system here. Things like load testing. Once you roll out this system, how exactly does it behave if you have, let's say, 1,000 users accessing it at any given point in time, rather than just 2 or 3 when you're conducting your system tests, right? How does the system behave? Stress testing is also a part of performance testing, right? Again, this is more when you're looking at load, to a certain extent, you're looking at stress testing, I suppose. So it is a form of performance test. So you're deliberately overloading the system to see exactly how it behaves. At what point does it fail? Now, for when you're conducting performance tests, some of the results that you get might not really be the defects that will arise, or the failures might not directly be associated with your system, but it could be the environment within which the system is deployed, right? So it could be that the hardware platform that you've used to deploy the system is not adequate enough, in which case you need to scale up maybe horizontally or vertically or something. But still, you are in effect conducting performance tests when you do that. All right, and then in terms of user acceptance testing stuff, I think we're going to wrap up this thing, which is good. This is what I was aiming for. In terms of user testing, and this is nothing more than acceptance testing, right? This is more applicable to custom software and not commercial off-the-shelf software, right? So you're looking at things like SIS here, right? You don't conduct user testing or user acceptance testing for Facebook. It's pointless, right? But you need to conduct user acceptance testing. Although you could conduct that, but you'd have to conduct user acceptance testing if a company approaches you and tells you, we will pay you X amount of Zambian kwacha if you develop this software for us. Once you're done developing, you need to go back to your clients and maybe deploy that system and have your clients test the system to ascertain that it actually does what they want the system to do, right? And there's all sorts of fancy things that you get to do here, and this is where the experimental software engineering part was supposed to come in here. So things like user experience, usability tests, all the good stuff here. Ease of use, right? These are some of the things that you'd have to test, I guess. All right, so yeah, performance, usability, robustness of the system. These are some of the things that you'd have to perform, I guess. I hope they will extend this thing. It would be nice if we cover that part, I guess. I don't know. Right, so the different types of user acceptance testing, again, here as the alpha testing, beta testing, and acceptance testing. In all these different instances, you are actually leveraging users to test your system, right? But there are differences in between alpha, beta, and acceptance testing, which is the final user test here. With alpha testing, the users will typically work alongside the development team to test the software. As the developers are still writing code, right? So this will typically be conducted on the developer's side here, if it's a large software development shop here. With beta testing, on the other hand, you make available the release of the software to the users to allow them to experiment with it. Typically, you probably deploy this on the user's premises and have them experiment with the software. And then finally, the final stage of user testing is acceptance testing, where the customers will test the system and decide whether they're okay with the software. Give a go-ahead to say, you can conduct the final deployment into our environment or something, or not, right? So at the bare minimum, you cycle through these 3 different types of user tests: alpha testing, beta testing, and then the final user acceptance testing. And just a visual representation here of what you go through for user acceptance testing here. Previous stuff, really, you come up with test criteria that you need to test your system against. So you define the acceptance criteria, you plan for the acceptance testing, you derive the acceptance test, you run the acceptance test, you interact with the customers to negotiate the results of the test, and then your customers will accept or reject the system. Usually, I guess, depending on, if you take an agile approach, it's really the case that your customers will reject the system, but who knows, right? There are crazy people out there. Now, a while back, when many years ago, I worked with a certain company. I did work with, it's not secret anyway, a company called Career Prospects. It wasn't really sophisticated, it was a web application, you know. And I remember we cycled through a number of iterations before they were okay with the website. Got to a stage where I got really irritated. I think the problem there was that I didn't follow through with an agile technique, I guess. That could have been the reason why, don't know. But they rejected the system on multiple occasions anyway. But eventually got to a stage where they were happy or okay with the system. All right, so in terms of the different stages here, just listing them from here, right? So you define your acceptance criteria, you plan for the acceptance criteria, you derive the acceptance test, you run the acceptance test, and then the crucial part is you negotiate the results of the acceptance test with your clients or your customers, and then the final stage is your clients will either accept or reject the system. Listen, I mean, in terms of V&V, I think that this should be sufficient for us to gain an appreciation of why this is important. I do believe it's important. It's sad that most developers will tend to neglect this part here. There's always this obsession when you're a developer that you just need to write code, right? You always think you know what you're doing. You write code, and then you just dump the system to the client and hope that they'll be okay with it. Most of the problems that will be highlighted by clients who would be users of the system as a direct result of comprehensive user acceptance tests not having been conducted, right? It is important that you do this. It turns out this is more of an art. So anyways, I don't know if people have any specific questions here. What I'm going to suggest is that on Thursday, we have an epilogue class on Thursday, just to wrap up, I guess. And then we have a test on Friday. But I still think we should maybe have 1 or 2 sessions, these tentative sessions, during the study break, so that we can just briefly talk about some of the things we were supposed to discuss. Suffice to say, the things we're going to discuss during the study period will not be part of the exam, but I just think it's important that we discuss them. So agile techniques and especially experimental software engineering, I think important if we talk about that, I guess. I don't know if there are any questions. If not, then I guess I'll just say we're going to part ways. I will see you on Thursday when we have our epilogue lecture session. All right, best wishes preparing for the test. Cheers, thanks. Oh, also, I will put up an assessment because I know people, so the assessment wasn't set up. The last deliverable is going to be the GitHub repository and a screencast of you showcasing the feasibility prototype, how it works, essentially. All right. Like I said, there'll be no report, but I'll put up that assessment, and it's not going to be. It will probably be due during the study period or something. So next Friday or something. Thank you, and I'll see you on Thursday then.